So welcome everyone to the second session of our Tech Talk series. Today, my name is Larry. I'm a senior pieces engineer here at Ignite, and I specialize in ScaleArc. And today, I'm going to be talking about load balancing, which is sometimes called read-write split, but also it's a little bit more to that. So just to give you a little bit of heads up what is going to happen in today's session, I'm going to first of all talk a little bit in general about the load balancing, just a small introduction to see why do we want to load balance our traffic, and then how does it actually happen within ScaleArc? How does ScaleArc do that? So this is those are the kind of the introduction to our load balancing. This is going to be followed by a simple demo of how does simple read-write split work in ScaleArc. It works out of the box, and I'm going to show you how does it work, and then we're going to go a little bit deeper into how can we make it work a little bit better, and perhaps a few kind of common setup actions that you might want to be familiar with, and then I'm going to dive a little bit deeper into kind of an aspect of data integrity and a few other settings that are there for load balancing that you might or might not have not been aware of, and but it is worthwhile to know them to make sure that perhaps there's a scope for a little bit of improvement to load balance your application a little bit more. Maybe there's some queries that can utilize the whole capacity of your infrastructure and are not. And this towards the end of the session, I'm going to try to answer all of the questions that you might have asked during the call. So please do not hesitate. Put your question into the question box, and I'll try to address as many as we're going to have time for. And if there are some questions that are answered, we're going to follow up on the email to make sure everything is well understood and answered. So to my first kind of point on our agenda, why do we want to load balance? And obviously there's a few obvious points on this list. First being we want to improve the performance. We want to utilize, we want to improve our user experience by leveraging this kind of increased capacity. And this is very critical. Now, what some customers we found might not be aware of, that sometimes this improvement of performance might be at no cost. Basically, if you think about it, a lot of times you have a whether it's a disaster recovery server or whether it's just kind of high availability clustered server sitting there and doing nothing. By load balancing some traffic into it, you might already have this capacity. You might utilize the capacity that you already have purchased, is paying for, are paying for, and you get this increase just by load balancing traffic into it. And that also leads to increased high availability. If you have servers that are not utilized, this kind of utilization of everything gives you this paradigm of always available server. So regardless if one is going down or the other is the new one is coming in, they all can be load balanced across and utilized. There's no need to change the application to point at new servers to be familiar with, because the load balancer takes care of all of this. One huge benefit of load balancing, especially in the context of disaster recovery, is the fact that you actually are utilizing hardware that is there sitting there, and sometimes this hardware might have not been touched for weeks, months, or so on. And in this case, there might be some patches missing. There might be some bugs that are not fixed or configured on the server. And if you don't actively use it all the time, you never know. And then this load balancing paradigm will put some traffic onto this server, some traffic onto the current server, but they will always be in constant use. And therefore, you will be 100% sure that if you decide to phase out one of the servers, the other one is ready to take over because it's already processing this traffic. It is capable. There is no known issues on this box or unknown issues. And speaking of issues and kind of this hardware related or server configuration related, perhaps there is a third-party agent running on one of the boxes, and it might be affecting the performance of one box. And in the situation when you are not load balancing your traffic across the nodes, you have no way of knowing. But if you do that, one hidden benefit is that you can actually compare performance of those servers in real time. If you have read replicas scattered across your data center and you balancing the traffic evenly across all of them, and you see one of them underperforming, maybe it has a little bit lower performance, maybe the queries are slower to respond. In this situation, it's an indication that perhaps there is some issue going on with this box. Maybe hard drive space is running low, or maybe some agent is running and affecting taking over some parts of the CPU. There might be various reasons, but if you don't have anything to compare against, you might expect you might not pick up this early on in the process. And last but not least, and probably perhaps this point kind of should be considered very critical in the load balancing context, is the ability to scale out. Databases historically were very difficult to scale out. They could have been scale up, but it's very difficult to scale out. Right now, SQL Server as well as MySQL and other technologies are coming up with the ideas of replicating the traffic, replicating the database, the data into other databases and servers. And load balancer sitting between the application and the database is enabling to just dynamically keep on adding those databases, scaling out depending on your need for growth. So this is something that is very, very critical in this context. Going further to our section, how does ScaleArc actually load balance the traffic? How is it different from ordinary load balancer? So ordinary load balancer, they would just pick up the IP, TCP/IP traffic or UDP traffic or whatever the traffic is, but on this kind of physical TCP/IP low level, and then it will load balance that across the bunch of servers. And there are smarter solutions. There are various solutions on the market, but ScaleArc is very unique in the way that it actually is able to decipher the protocol, extract the SQL queries, the actual queries that are running within this protocol, and understand their context. It understands the sessions that are being established from the application perspective. It understands the transactional nature of those queries, perhaps. It understands all of this, and it is able to recognize which is a read-only traffic, which is a read-write traffic. And as such, it doesn't require the developers to specify, saying, this is a read-only traffic. And with SQL Server Universe, you would need to say this is a read intent connection, and you would utilize this other connection for read traffic, but one connection for write traffic. In MySQL, it's no different. You would still need to connect to your master node for any write queries, and then connect to other servers for read-only query traffic. And ScaleArc mitigates that problem altogether. Essentially, it is able to understand SQL and route the traffic accordingly. So as such, it's a very valuable piece of, very valuable load balancer from that perspective, and very unique. And one thing to bear in mind by introducing load balancer into your application architecture, you actually enabling yourself to dynamically change. ScaleArc is fully capable of making changes, and you're going to see that during the short demo that I have prepared for today, that you can adjust settings of this load balancing. You can change your behavior, you can change your routing, and then those changes immediately takes place within your live environment. So as such, you can actually mitigate a lot of issues during runtime when you're running your application. So with no further ado, I'm going to jump into a short demo, but just before I start, there are two settings that I want to emphasize here. In some cases, you might find that perhaps the read-write split is not behaving as it expected. Maybe it's not load balancing across the other nodes at all. And there are two settings that might be at cause here. One is the authentication offload. So as you might imagine, ScaleArc pre-authenticates all the connection, and in order to load balance the traffic across all the nodes in the cluster, it needs to be able to offload this authentication and re-authenticate against those nodes. Therefore, this feature, the authentication offload, needs to be enabled for the load balancing to be able to work. Otherwise, the authentication traffic will just be passed through to your master node, and therefore ScaleArc will not be able to reestablish those connections to other nodes in order to load balance this traffic. Another option is a pass-through option, and it's very unlikely that you had it switched on. It's only in a very rare circumstances that you would want to switch it on. Sometimes, perhaps when you're testing something, debugging some issues or something like that. But essentially, this option is in the debug panel and in the cluster settings, and it needs to be. You just need to make sure that it's switched off. If you ever see all the traffic going to one of the nodes of your cluster, it's worthwhile checking if this option by any chance hasn't been switched on. So let me jump into my ScaleArc session to demonstrate how does actual read-write split work, and how does it look like in the live environment. So let me just start with the cluster here, just to familiarize yourself with all of it. And this is the cluster that I'm going to be using for the demo. It's an always-on SQL Server cluster. I have another cluster which is actually Aurora DB cluster. I'm not going to be using this one for the demo. I'll use this one, and it has 3 servers. Our master server, which is our primary node, or read-write node, and then slave 1 and slave 2. And in order for us to see what is going on the server, I'm going to jump into our live monitoring screen, which is called cluster stats. And in here, I've triggered, in behind the scenes, I've triggered some traffic generation tool. It's actually generating some traffic, about, I don't know, up to 40 client connections going at any point in time. It varies a little bit, of course, and then what I want to show on this interface, the most important screen in the context of read-write split is this one here. And the reason for that is it is actually showing how many read queries are hitting our database and how many write queries. And you can see that we have probably around 60-40% split between read and write. And so this is the graph that is very critical. And below that, we can also see the distribution of those queries across our cluster. We can see that those are perhaps our write queries going to our master node, and then our read-only queries are actually being scattered across 2 other nodes. And of course, the response times. And as expected, the master node will be the slowest responding node, purely because it is handling the write traffic, and the other one are read-only traffic, so they're a bit faster. So this is this feature here saying that which traffic is read, which traffic is write, is working out of the box, and you basically need to do nothing. Just define your cluster, start traffic going in, and this is what you would see. Now, one thing that I know here within this kind of traffic that I'm generating there behind the scenes, that it is actually not a 60-40% split. It is more of an 80-20. But the reason why it's actually routing some read traffic as write, categorizing as write traffic, is because it's utilizing stored procedures. And ScaleArc philosophy is, first and foremost, that it does not interfere with any current application logics. And therefore, due to the nature of stored procedures, their transactional nature, their isolation, it's by default, ScaleArc will not consider stored procedure read traffic. It is able to recognize whether a store procedure is a read-only store procedure, but it will not leverage this information to load balance the traffic. We need to tell ScaleArc it is okay to do so, and only then ScaleArc will start doing that. And let me show you how to do that. So first of all, if I go to my log files here for this database, just to show you the store procedure, there is a culprit here, and I know the name of it, and I'm going to search for the entries for this store procedure. And one thing to note here is that our query type is a write query. And I know this is a read procedure. So, but because it's not, I haven't gave the thumbs up for load balancing the store procedure to ScaleArc, it is categorizing as a write store procedure. So let me show you how to categorize it as a read store procedure. I'm going to jump into my cluster settings from the main screen, and then on the ScaleArc tab, there's an option called write ignore. And first of all, we need to make sure that this option is enabled. But once it's enabled, if I go and set the rules for the database that I'm utilizing within this demo, and I have a list store procedure button here. And this button is very useful because essentially what it does, it fetches all the metadata for the store procedures from our database, and it allows us to pick into them. So we can see that this is a simple store procedure. It's just basically running 3 select statements. Similarly, this is a write store procedure, and it's running some if statements and updates or deletes. So those are the store procedures that we have. And I'm going to mark the read-only store procedures, those two, and add them to my write ignore rules. I just need to make sure that they're enabled. I will save that option. And right now, what happened in behind the scenes, dynamically ScaleArc will start routing this traffic into across all of our nodes. So in order to see that, I'm just going to go back to our status, cluster stats, the live monitoring screen. And what we will see here, that this red line went down a little bit when I added the rule, which means that right now a lot less traffic is categorized as a write traffic, because that accounts for store procedures that I've just created the rules for, and then a slight increase in our read traffic. And just to show you a little bit deeper this information, just to kind of understand what's going on now from the log perspective, I'm going to go back into our log section here. I'm going to search for this. And we can see that this is now categorized as a read traffic. Yeah. So this is now read traffic and not write traffic as it was before. So right now we're good to go. We basically have our store procedures. We gave ScaleArc thumbs up, saying, okay, now you can actually leverage that feature. So just refresh it, and let me jump back into my presentations for a minute. And so we went through this kind of read-write split in general, how it works. Very simple. It just works. You direct your traffic through ScaleArc. You configure your cluster, and ScaleArc will start routing the traffic across all of your nodes in the cluster. Now, and we went through the store procedure, how to give a thumbs up for ScaleArc to load balance store procedures. Now I'm gonna go a little bit deeper in this presentation to kind of the concept of load balancing on the query level, on the connection stickiness, and kind of how to create the specific rules. And this is all in kind of data integrity and fine-tuning your caching rules to benefit the most of it. Because as you can imagine, you might want to leverage this even this further to a further extent, this load balancing feature. And I'm gonna show you how can you achieve that using this query level load balancing feature in ScaleArc. So in order to do that, let me open my ScaleArc screen again. Let me jump back into our cluster section. And in this load balancing and routing section of our cluster, we have those bunch of options. And a few options are read-write split. This is, of course, our classical read-write split, which we've seen working and in action. There's very little reason to switch that off. The only situation where you might want to consider switching that off is where all of your nodes in your cluster are essentially equal. So, for example, if you have only read-only nodes in your cluster and you basically don't care, you know your traffic is 100% read, and you just want to purely load balance it. You don't want to leverage this recognition, whether it's a read or write traffic, or the other way around. If all of your nodes are actually write nodes, and you don't want to load balance this traffic, you just want to load balance across the whole cluster. So though this you would want to switch that off, then very rare situation. So I'm not gonna demo that, but what I will demo is this query level load balancing. And in order to do that, I'm gonna switch those options to off. And what's gonna happen now, I'm gonna open a SQL command session. Let me just re-trigger this connection just to make sure we're starting with a clean plate. I'm gonna log in, and right now I'm gonna do select server name. What that gives us, it gives us the server name of which server are we connected to. And if I keep running this query, you will notice that every time it will hit the same MS SQL slave 2. And the reason for that is because our query level load balancing is not enabled. As soon as I enable this option here, let me enable this option. Right now, if I run this query again, it's going to be started load balanced across the whole cluster. Perhaps I might need to run it a couple of times, and you can see that right now it went to slave 1. And if I run it again, it might actually run into master, slave 2. It might hit any of the servers because it's just read-only query. And yeah, right now it hit master. So this is the kind of change of the notion of whether the load balancing should happen on the connection or whether it should happen within actual connection. So imagine that you have an application server that is running a constant, like a persistent all the time connection to your server, and it doesn't reestablish it. Perhaps you're polling the connections within the application. Perhaps there is some other intermediary application that is basically polling those queries, some REST API in behind the scenes for the website or something like that. And in these circumstances, your connection will be load balanced on connection. Now, of course, that's not going to bring the utilization to your word of your full utilization across your hardware. So you would want this this feature to be enabled. Now, you might ask, okay, well, if it's connected to slave 2, and I want to perform write, what happens then? So ScaleArc by default is upgrading your connection to a write connection. If I perform a simple update statement here, I'm just going to do a simple query that changes nothing, but it is triggering a write statement. Sorry, so OTP1. There you go, and it's just updating 100 rows, touching them, doing nothing significant, but it upgrades our connection to a write connection. So right now, every time I run this, it's going to be hitting our master server. I'm going to show you this. Just going to copy and paste this query a couple times just to prove my theorem. Master, and it will continue on hitting master server because this connection is now upgraded to a write connection. So this way, by default, ScaleArc will always be consistent in what it's doing. So if you have application that runs some select statements and then it decides, okay, now I want to write query, and then it will start selecting, let's say it's the identity of last inserted record or those kind of things. this connection is now upgraded to write connection, and it's pointing at our master node. So in this notion, the behavior is again defensive. ScaleArc does not want to interfere with the application logics, so it will never downgrade the connection. But again, going back to our long-running connections within our applications, we might actually want to downgrade it at some stage. And in order to achieve it, there is another option here within ScaleArc, which is called stick connection on write queries. And of course, by default, connection is sticky insofar that whenever write query is triggered, it will stick to this to the master node. But this enabling this option actually enables you to define how many queries after your initial write statement, your initial update or insert or delete, will be actually routed to this master node. So if I leave this as 1, and this is of course automatically updated already, and if I go back into my session here, if I run my query first time, because this connection was write connection, it will go to master. But if I run it the second time, it will be load balanced across other nodes. So this time it was load balanced to slave 1. And again, if I run my update statement and my connection select statement, it will go to master. Second time, it will go to some other node. So in this way, we can define, and it could be 1, it could be more. You probably want to select an option which is somewhere in between, making sure that your data is consistent after the write queries, but at the same time to leverage the overall performance of the whole cluster. So if you have these long-running connections that are reused, and the writing and reading, you might want to look into your queries a little bit, into the log file, figure out how many connections do I want to stick, how many queries I want to stick to the master node after write, update, delete, insert statements, and then leverage that functionality. And one other function that I want to show you here, and it's a little less popular function, but it's actually very powerful, I would say, is the query routing function. And this function can be used to segregate traffic, for example. Imagine you have a backend interface or reporting service that is accessing the same data as your customers, as your users. And perhaps you don't want this backend interface or dashboard or some other application to affect the performance for the users. So you might want to segregate and narrow down this traffic for this particular user, for this particular database, for this particular query to a one and only server node. You can achieve it here. So I'm going to create a simple rule here just to demonstrate how it works for our ScaleArc user that I'm using, our ScaleArc demo 1 database. I'm going to create this rule, and we can obviously stock it into, we can define an IP as well if we want to do it this way. And in here, I'm going to edit those options, and I'm going to add a rule. And I'm going to write my select server name pattern in here, and I'm going to route it to slave 1. So right now, and if I enable it and save it, right now I would expect this query to always return MS SQL slave 1 name. Let's give it a try. So I'm going to run this query now. And as expected, it returns MS SQL slave 1. If I run it again, it will again return MS SQL slave 1. Now, one thing you need to remember here, if I run my update statement and I run this query again, this routing rule overrides all the connection stickiness, all the query level load balancing. This basically is the decision maker then. So you just need to bear in mind that if you define those rules, those queries will be following those rules and not the other rules. And one other thing that you might have noticed, I'm going to go back to the interface now for a second. One thing that you might have noticed is that there is a and or box here. So within this dropdown, I could select multiple boxes. And when I do that, if I select and value, it will tell ScaleArc to load balance across those nodes that are selected. If I select or value, it will only fall back to the second node if the first node is not available. So this is good if you have your dashboard or if you have your reporting service pointing at one server. But perhaps you might want to, if there is no more servers available, you might want to fall back onto another box. So in this way, you can define your hierarchy of queries. Where will they be executed? So let me go back to my presentation for a second and do a quick recap. So we went through a simple query level load balancing. I've displayed and showed how does it affect the actual connection and how it does differentiate from connection level load balancing, whereby connection is executed and then sticks to one server until the right query is executed when it gets upgraded to a write node, to the master node. Query level load balancing allow to actually even on one connection load balance queries across various servers. Then connection stickiness, which is a very important rule, which can allow you to have a much greater utilization, much greater kind of this spread of your load across your servers if you can make this decision of saying how many queries after an update or write or an insert delete queries can be considered safe to load balance. And within environments when you have where you have very low replication lag, this number does not need to be huge. And then I've showed you how to kind of define a simple traffic segregation rules, query routing rules. And you can imagine that you can perhaps define a rule for a particular user to that would say .star, which in regular expression means all the traffic, and then ScaleArc it will enable ScaleArc to direct all the traffic for the particular user to one server. So this might be super useful in some circumstances. So going further, there's a few settings, few other settings that are worth mentioning here. Once we're talking about load balancing, and first of them is the load balancing strategy. And there are two strategies that ScaleArc has. One is a dynamic strategy, and this is on by default, and the other one is round robin strategy. And you can imagine round robin is just moving from one to another, is just basically spreading the load evenly. Now, there is a very little use case for that strategy. We have not seen a lot of use cases. The dynamic is the default option, and we strongly suggest to kind of try to use that purely because it takes a lot of aspects into equation when it actually balances the traffic. And as you might notice there below this kind of in this there I have 4 points, and yes, exactly those are one of the aspects that there are some of the aspects that this dynamic load balancing takes into equation, which is replication lag, the maximum amount of connections or the connections opened to the actual servers, the response time from the servers actually. So and then a weight of the server. So all of those aspects are considered within load balancing, and basically what ScaleArc does, it is favoring the nodes with low replication lag, very fast response times, lower connection amount perhaps, and then basically we can specify the weight of the servers if we want to. So those are the kind of aspects where what ScaleArc takes into equation, and I think in a lot of cases, in most of the cases, those are the ideal aspects, purely because if you can imagine, there is a replication lag, there is a higher replication lag on one of the databases than on the others. You do want to route traffic away from this node a little bit, so perhaps you can catch up with others. Maybe it's further down in different availability zone, or in some sort of behind some firewall that is adding latency, and it's replicating just slightly slower than other servers. You might want to give it a little bit additional bandwidth, additional kind of capacity to kind of catch up, and similarly with other aspects. And just to kind of reiterate that, I'm gonna go into ScaleArc for a second, just to give you an idea where to look for those options and how do they work. So in cluster settings, on the server tab, we have this ignore replication lag time option, which basically suppresses this functionality. It removes this from the dynamic load balancing equation. Now, another option to bear in mind here, that there is maximum replication lag as well. That's slightly different, although not entirely irrelevant. Basically, this value defines the replication lag at which point the server is going to be marked as offline by ScaleArc. So ScaleArc will monitor replication lag on your database if you configure it to do so, and then it will decide if there is a huge replication lag. There's definitely something wrong with the database. I'm going to put it offline because there's too much risk in load balancing traffic into this node. So you can suppress this option here, and then all the other options are actually a part of debugging aspect, because not very frequently you would want to change that. In very special scenarios, very rarely you would want to ignore server response time or max connections to the actual server. One option here, and it's on by default, which is weight-based load balancing. So in some circumstances, in particular when you have your database perhaps scattered across different geographical locations or something like that, you might want to prefer routing traffic into your local hosts than to the remote hosts, or you might want to just basically route away 5% of your traffic to your beta host, on which you would do pre-releases to make sure that everything is working. So you could leverage this weight-based load balancing, and in order to do that, you just need to switch off this kind of suppress option, and then once you do that, you will be able to define which node should be preferred just by using the slider here on the cluster settings. So those are the kind of options that can affect the behavior of dynamic load balancing. As I mentioned, there is another option, round-robin load balancing, and you can set those options in the advanced section of the cluster settings. You can change the strategy. We don't usually advise to do so until there are very specific circumstances or a specific use case. So this will conclude this session. We went over a couple of aspects of load balancing, what works out of the box, what are the fine-tuning sessions, what are the other options. And right now, I'm going to move to a Q&A section. Susan, are there any questions online that we can address?
Yes, Larry, we actually did get a few questions in. Our first one is, would load balancing work in a hybrid on-prem cloud environment?
Right. So exactly. So this is a good question insofar that technologically speaking, absolutely no problem. And one thing you need to bear in mind, that if you have this replication enabled between on-premises and cloud, you might want to leverage the weight-based load balancing feature of ScaleArc. Perhaps you might want to adjust your settings slightly. But absolutely, this is a common scenario, and we have customers that are running such environments. Any other questions, Susan?
Yes. How does ScaleArc deal with transactions during load balancing?
That's a very good question. So in some circumstances, you might want to explicitly or define your transaction just basically by saying begin transaction and then commit transaction. You might want to, whether it's a booking application and those kind of things. Now, the default behavior in ScaleArc is, of course, that it will lock any traffic that is covered within transaction. It will lock to the master node, and this is the behavior that is probably expected 99% of the cases. Now, in some cases, rare cases, we've seen situations whereby there are some queries within these transactions that perhaps can be cached or load balanced, and there is such option in ScaleArc. I have not went into this detail into this detail during the presentation because it's a because of time constraints, and it's a very specific and rare use case. But if you're interested in such use case, please do not hesitate to get in touch with us, and we can guide you through this process and basically help you setting up. Any other questions?
That is all the questions we have today. I'd like to thank everyone for attending today's Tech Talk. As a reminder, we have 3 Tech Talks left in this series. When we meet next week, we'll discuss consolidating database analytics into a single platform to allow administrators to make more efficient and intelligent decisions, saving time and money. On behalf of Ignite Technologies, thank you for joining and enjoy the rest of your day.